and we're dealing with trig, but we're only dealing with
Quantanner.
Wow.
right triangles. Okay, and it's a it's a start. Where what happens is they use the right triangle trig in order to apply it to any triangle, but baby steps. That's why first is 4.1. So you've dealt with this probably in Algebra 2 geometry, the basics, sine, cosine, and tangent, also known as what? In order to remember, they have
SOHCAHTOA.
Right? Sine is opposite over hypotenuse, cosine, theta is the angle, equals adjacent over hypotenuse, and tan is opposite over adjacent. Stop talking.
All right.
All right. So in this case, when dealing with the triangle, hypotenuse will always be the same. Yes? But the opposite and adjacent is according to where your theta is, where your angle. And in this case, my theta is here. So the adjacent is the side that touches it, and the opposite is the side that's right across from it that doesn't touch it. Right? So if my theta was over here, this would be
Opposite.
and this would be,
Adjacent.
we understand? Yes?
Here, what was there?
If my theta was here, because my theta is here right now, right? My angle. If my missing, or if my angle that we're dealing with is here, right? That means this would be opposite and this would be
Adjacent.
adjacent. But the hypotenuse always stays the same. It's the one that's right across from the
Right angle sine.
right angle. Yes? Are we understanding? Now, the new ones that some of you guys may or might not have seen is cosecant, secant, and cotangent. They are the inverse of these ones. So the inverse of sine is cosecant, right? So that means if this is opposite over hypotenuse, the inverse would be
Hypotenuse over opposite.
hypotenuse over opposite.
Oh, that's all?
Yep. Cosine is cosine theta is adjacent over hypotenuse, so secant is,
Hypotenuse over adjacent.
and then tangent is opposite over adjacent, so cotangent would be. See how that works? To get the same value, but it's the same concept. It's the inverse, right? So I can also do the inverse of sine as 1 over sine, right? Which will give me cosecant. So another way of finding it is to put 1 over whatever your value. So let's say they don't give you opposite over, they don't give you a fraction. They just give you the value of sine theta. Then you can put that under 1 and that becomes your cosecant. You with me? Same thing with cotangent. Since it's the inverse, I can take 1 over tan theta. And then this one is secant, which is 1 over cos theta. That's not easy. Yes? So this down here is just different ways of writing the same thing here. Okay? Same end goal. So tangent theta, I can also write it as sine theta over cosine theta. And cotangent theta can be written as cosine theta over sine theta. Now, what is the benefit of knowing how to rewrite it, knowing the same value, but rewriting it differently? What's the point? Why give you these when you already know what this is?
You don't have the other ones?
Right. So in case they don't give it to you simply in a fraction that you can flip, if they do, this is your default. Yes? But if they don't give it to you and they give it to you as tan theta, then you can use these to find what you want. Okay, it's the same concept all through math. They give you the clues and then you have to figure out to solve what you're trying to solve. So it depends on what information they're giving you. They might not give it to you in just fractions, therefore you're going to need to know this information. Now, will you need to memorize it for the test? No, it'll be written, but you got to know what it means. Questions? I mean, I won't write it. You'll have to write it if you want to. Questions on this? Yes. Okay. All right, so the first one here, we're trying to find x. Now, the theta in this situation, it all depends on the angle before we solve. So the angle here, okay, before we figure out, everyone pay attention. The goal has always been the same since day 1 of math, right? You figure out what you know, and then you find what you don't know. So let's figure out the clues that they give us. Here is my angle. My theta is 35 degrees. So according to the theta here, the angle, right? what information do I have? What is this? This is my hypotenuse, and this is my
Adjacent.
adjacent. So according to this, I need to find which one deals with hypotenuse and which one deals with adjacent. Hypotenuse and adjacent. Which one would that be?
Cosine?
Cosine. So I find cosine of theta equals adjacent over hypotenuse. Yes? Then fill in what I know. Remember, I can have a maximum of how many missing variables?
One.
Just one. So if I fill it in and I have more than one, then I have to figure out another way. Do we understand? Okay, so we have cos theta. So my theta is
35.
35 equals adjacent, which is over hypotenuse, which is, so I'm going to put this over 1, cross multiply and solve. So this is 7 times cos 35 equals 1 times x. Yes? Pull out your calculators and please find cos 35 and times it by 7.
5.73.
Well, how many decimals does it say?
I don't know.
How many we need? It's a lot of decimals, so.
Right.
I stopped at the third.
It says...
What?
Riley wanted to take
Here's
the phone
10.
from him.
So what is it?
Hey, it was Riley. Promise you.
I can see him.
Can you see his right hand?
Yeah?
Yes? Hey, I need you guys to check, because you have it has to be in degrees, not radians. So I need you to actually fill this out, and if you're not getting 5.7, your calculator's in the wrong setting.
SP.
Yeah.
Who named them? Like, cosecant. Like, that.
I don't know.
That's
We'll
weird.
research that. I don't know.
Extra credit.
Just weird.
That's why, if you discover something, you can name it whatever you want. That's why we have some ridiculous names for ridiculous.
That's
Maybe we just name it like blueberry muffins or something like that.
Blueberry muffins are a thing.
Wait, it has to be in degree, right?
It has to be in degree mode, so if you're not getting 5.7, it's in the wrong one. Grab one of these, because we have to finish this
Which
up.
company, like,
Okay.
if you switch it from rating?
Let's go. Guys, pay attention.
Yeah.
It's the same concept here, right? Except in this case, our theta is missing, our degree. But we have to still figure out which one of the ratios we have to find. So in trig, I didn't know if I went over this. For trigonometry, it's basically we're using the measures of triangles and finding the relationships between sides and angles, right? Something common that you use is pi. You guys know what pi is? What is that?
3.141.
Well, its circumference is 3.14 times bigger than the diameter. That's where this comes from.
So if you
These are
divide the
ratios.
circumference by 3.1 for you, always get the
Diameter. That's right. So that's the ratio. That's what pi is. It's actual value ratio. Does that make sense? That's what we're dealing with here. So this one I have to do the same thing. My theta is here, but according to this angle, what is this?
The opposite.
And what about this?
Hypotenuse.
Right? Opposite, hypotenuse. So this one, I have to figure out which ratio deals with opposite and hypotenuse. Which would that be? Sine theta equals opposite over hypotenuse. So let's fill out what we know. We have sine theta equals opposite, which is 12, and then hypotenuse, which is 15.7. Yes? So in this case, I'm not doing the same thing as here. I'm not going to cross multiply. I'm going to find this in decimal. What is this in decimal?
I didn't do it.
0.76.
Yeah, 0.7.
We're going to have this on camera, on the video, so if you need to rewatch the beginning part, I'll have it up tonight.
Okay, alright, thanks.
76433121002.
Okay, so this will be 0.764. Yes?
Yes.
Okay? So in this case, I'm solving for theta. So to separate sine and theta, I have to do the opposite of sine, not the inverse. So I'm not going to do secant. I needed to do the opposite sine, which is sine -1. Sine -1 of sine, right? It cancels out, leaving me with just theta. And what I do to one side, I have to
Do the
do to the other. So I have to do sine -1 of this. What is that?
It is 49.84.
10th place.
49.8.
Now, because this is theta, my answer is in degrees. Now, it's the same concept that we're using for all of these right triangles. Number 3 would be the same, it's just they want you to draw the picture. But we're just going to focus on solving. So when they solve the triangle, are we done?
That number is an 8, right?
No, that's an F.
This is an F.
Oh.
Okay. Huh? How many parts of a triangle are there?
3.
6.
6.
Yeah.
We have 3 sides and
3
3
angles.
angles. So when they say solve the triangle, it's basically asking you to find all the missing parts. So this one we have 2 angles. We have a missing angle here, and then we have only 2 sides. I mean only one side. So we're looking for 1 angle and 2 sides, and you can start anywhere, right? So let's start with
48.6 is the other angle.
Yeah, he's right.
what?
48.6 is the theta.
Right. But we're gonna focus on finding the sides first. So we have 41.4, right? So this one, this is according to what right here? According to theta, this theta,
Yeah.
what is this?
The
Adjacent.
adjacent.
What about this one?
Opposite.
Opposite, right? So in this case, I'm not looking for, I need everyone to pay attention. I'm not looking for a ratio that's opposite over adjacent, because that would give me how many missing?
Oh, that would be 2.
2.
Oh.
I would have F and H missing. And I need to find ratios that will help me with only 1 missing. So I have to have either a theta, hypotenuse, and opposite, or a theta, adjacent, and hypotenuse. Doesn't matter which one you start with. Let's start with one with adjacent, okay? So something that has to do with adjacent and hypotenuse. Which one would that be?
Cosine.
Yes? Cosine, adjacent, hypotenuse, right? So cos of 41.4 degrees, I don't do degrees, equals adjacent over hypotenuse. So H over 28. Now, I can again, just like the first one, put it over 1, cross multiply and solve. So I have 28 times cos 41.4 equals H. What does that give you? 10th place, just 21.
It's 21.003, so.
So this is H. Now, I can now plug in H here. Here's the thing. I can now plug in H here for my adjacent and then use that to solve the triangle. But if you do that, then if this is wrong, your other measurements will be wrong. Does that make sense?
Yeah.
So if I were you, I would continue using, unless you absolutely need these, use the angles that you are 100%, the angles and the sides that you're 100% sure of. Yes? So because of that, because of what I just said, I'm going to focus on this, and instead of adjacent and hypotenuse, I'll still focus on opposite and hypotenuse. What would that give me?
Sine.
So sine of 41.4 equals,
That's over 28.
so this then, I cross multiply and solve, so 28 times sine of 41.4 equals
18.5.
F.
Oh.
18.5.
Yeah.
Now the last one, I could use a ratio, or I could do what Riley probably did, which is all the angles in a triangle add up to
180.
180. So I do 180 minus 90 minus 41.4,
Yep.
which is 90 minus 41.4, which is
98.6.
Yeah, 48.6. Alright. I wasn't thinking. I wasn't. I knew what I was thinking.
this is H in English.
Just got back from break. When were you sleeping?
Oh, I was sleeping, but now I, didn't sleep like 12 hours last night, so.
Sleeping now.
Please pay attention to how they label this. I don't know if you remember this from geometry, but opposite sides are labeled with the lowercase of the angles. So all my angles are uppercase, right? And the opposite side is h, this is little g, and this would be little f.